How do you make sure that your application's users can only access sensitive healthcare data that they are authorized to? Hi, I am Bashir Sadjad, a software engineer on the Open Health Stack team at GoogleHealth. Open Health Stack is a set of open source components that are created to accelerate adoption of digital healthcare solutions that leverage standards like HL7 FHIR. In this video, I am going to introduce you to the FHIR Information Gateway and show you how you can use it to solve the access control problem that I mentioned in the opening. Before we start, a quick word about FHIR, which stands for Fast Healthcare Interoperability Resources. FHIR is an open, modern healthcare standard from HL7, designed to improve data sharing and collaboration among different healthcare systems. The specification provides guidance related to enforcing access controls and security, but it doesn't provide details about how to implement these. If you are not familiar with the FHIR standard or the relevant modules, please follow the links shared in the comments below to learn more about them. Let's dive in. The FHIR Information Gateway, or Info Gateway for short, was born through a natural need for mobile apps that were developed using OHS Android FHIR SDK. You can learn more about it in earlier videos. That need was controlling the app's access to the backend FHIR server and to improve sync operations. The Info Gateway is designed to solve a more generic problem, that is access control for any client. It might be a web-based dashboard used by program admins. It might be a mobile app used by community health workers, possibly with offline support. Or it might be a personal health record app used by patients. And even for backend systems access control needs. For simplicity, this last use case is not covered in this video. There is also another aspect of being generic. The Info Gateway is designed to work with any service that implements the FHIR API. In other words, it makes no assumptions about the actual FHIR server implementation or internals. This is important because we want developers to implement their access control logic once and then use it in front of any FHIR server. The Info Gateway is in fact a FHIR server itself, which proxies the requests to the actual FHIR server containing resources. So it acts like a FHIR facade. Before getting into the details, let's make sure we are on the same page about some terminology. To decide what an app user has access to, we should first establish who the user is. This is the problem of authentication and might be done through a shared or a special purpose service. This service is called the identity provider. For example, Google provides a shared authentication service, and that's what you see on all websites that have the option of sign in with Google. Authorization is the problem of deciding what the authenticated user has access to. Access control is to make sure that a user's access to data is within their authorized limits, and this is the main focus of the Info Gateway. Finally, we heavily rely on OAuth 2 and its related standards. These standards are for granting access to an application on behalf of the user. We won't get into the details of these standards in this video, as there are plenty of resources on the web for them. This figure shows the general architecture of the services involved when deploying the Info Gateway. When a client requests access to some FHIR resources, it must provide a valid access token in the form of a JSON Web Token or JWT, issued by a trusted identity provider service. This token may additionally include specific access scopes that are granted by an authorization service. The identity and authorization services might be provided by the same server or separate ones. Regardless, the info gateway will determine if the provided access token is valid and extract authorization information from it. The core functionality of the info gateway is stateless, which makes it easier to horizontally scale the gateway service. This is also our recommended way of implementing AccessChecker plugins, which we will discuss next. The actual logic to decide whether grant access to a request or deny it is not always generalizable. So we have separated this logic into an AccessChecker interface, which is called by the core gateway request processor. This logic can be provided as a separate plugin for the info gateway. We provide some out-of-the-box plugins that cover common cases like smart on FHIR applications, and also serve as examples for developers to write their own custom plugins. A common pattern for defining healthcare data access boundaries is to build them around patients. In other words, the user may have access to the information for a particular set of patients. Access should be granted if the query only touches the data for a subset of those patients. Info Gateway provides some libraries to enforce this pattern. Also, as an out-of-the-box example, a list access checker is provided where the set of patients is defined by a list resource in the actual FHIR server. To decide whether a resource belongs to a patient or not, the patient compartment definition of the FHIR spec is used. Note the list of patients doesn't have to be explicit. It might be defined by implicit rules. For example, an implicit rule might be based on the general practitioner field of patient resources. So only health workers listed in the general practitioner field will have access to that patient's data. Another AccessChecker plugin that is provided out of the box implements access control requirements for a standalone patient-facing Smart on FHIR app. The patient ID is determined during the authentication process and is included in the JOT. Authorization scopes are also attached to this token. These scopes should follow the Smart on FHIR scopes pattern, which have built-in support in the info gateway. As an example, this snapshot shows the integration of the growth chart smart app. No changes in the code of the app was needed. We just pointed the app to the info gateway and everything worked from there, which is the beauty of building around interoperable standards. The data in the FHIR server shown here is of course synthetic data. The info gateway is not opinionated about where the authorization rules come from. An AccessChecker plugin may take this information from the access token itself or load it from the FHIR server or even another service dedicated to ACLs. And as mentioned before, the access rules may not even be explicit. For example, a very simple authorization strategy may only require an external OpenID Connect-based identity provider service. Once the identity of the user is established, the implicit rules can be applied when deciding what the user has access to. Implementing the info gateway as a facade around the FHIR server brings its own limitations as well. For example, let's assume that the user has access to the patient with ID/PID. Then obviously, access to the FHIR resource /patient/PID should be granted. But what about a /observation/OID query? How can we tell whether this observation belongs to patient PID? An AccessChecker may choose to simply reject this request. It will require the subject patient to be provided at query time. Another AccessChecker may fetch the observation resource from the FHIR server and then in the post-processing step decide whether to send it back to the client or not, depending on the subject field. There are also some limitations around various forms of joins. For example, chaining and reverse chaining FHIR search queries pose unique access control challenges and are disabled by default. In this video, we learned about the FHIR Information Gateway component of the OpenHealth stack. This gateway is a generic access control reverse proxy. It provides a flexible AccessChecker plugin architecture. An AccessChecker can use one or more of the following techniques to decide whether to grant access to a FHIR query: patient context enforcement, templates for allowed or blocked queries, rewriting queries, for example, by adding extra query parameters, and post-processing of the resources returned from the FHIR server. The gateway is designed to be generic, that is, to work with any client and FHIR server. It can also be used as a middleware for enhancing sync operations between clients and servers. To learn more about the FHIR Info Gateway's features, explore our website's developer documentation and the GitHub repository. We also have community forums and regular developer calls that you can join. See the links in the comments below. To keep learning about how to build with OpenHealth Stack, check out the next video in our series.